The topic is vertical asymptotes. So let's read the definition. Let f be a function not defined at x equal a. So function shouldn't be defined at x equal a. If a limit of f of x as x approach a from the right side is either minus or positive infinity, or a limit of f of x as x approach a from the left side is either negative or positive infinity, then we say x equal a is a vertical asymptote for y equal f of x. Alright, for this example, we need to find the vertical asymptote for the curve y equal 1 over x. So we can see the graph here. So first thing, we need to find the x values where the function is not defined. And we can tell here y equal 1 over x, the domain is all the numbers except 0 because it makes the denominator 0. So the domain is negative infinity 0, union 0, infinity. So now if there is any vertical asymptote, it will be at x equal a, which is 0. A happens to be 0 in this problem. So we do limit of our function 1 over x as x approach 0. We're going to do the right side and left side. By looking at the graph as x approach 0 from the right side, if you follow the graph, you know this is going to be infinity. Now same thing, a limit of 1 over x as x approach 0 from left side. If we follow the graph from left side, it's not going to touch. Then this will be negative infinity. So we can say that x, therefore, x equals 0 is a vertical asymptote. And you can tell from the graph, this is what we mean with vertical asymptote. It gets closer, the curve gets closer and closer to it, and it's a vertical line. Now, for the second problem, find the vertical asymptote if any of the curve y equal negative 5 over x. Well, I did this example just to show you how to find a limit this time without doing the graph. So we can use, so kind of like, now we're going to assume that we know the limit of 1 over x as x approaches 0 plus. It's always going to be positive infinity. So, the same thing here, the domain doesn't include the 0. Same domain, negative infinity 0, union 0, infinity. So when we do limit, we need to find the limit of negative 5 over x as x approaches 0 from the right side. And this is the same thing as limit of negative 5 times 1 over x as x approaches 0 from the right side. Now we know that this part, this limit, is going to be of 1 over x as x approaches 0 plus is positive infinity from example 1. Negative 5 times a large number times positive infinity will give us a negative infinity. Right? A large positive number times negative 5 will still be large, but it's going to be negative number. Now same thing, we need to do limit negative 5 over x as x approaches 0 from left side, and this is going to be equal limit of negative 5 times 1 over x as x approaches 0 from left side. Now limit of 1 over x as x approaches 0 from the left side is negative infinity times negative 5 will be positive infinity. And you can tell from the graph, and this is how the graph of minus 5 over x look like. If you graph it using your calculator, this is what you get, and it makes sense. As x approaches 0 from the right side, it's going here towards negative infinity. From the left of 0, it's going towards positive infinity. So in this case also, we say x equals 0 is a vertical asymptote. In the next examples, we're going to use the fact that we know limit of 1 over x as x approaches 0 will be, from the right side is positive infinity, from left side is negative infinity. Alright, so that's it for these examples.